Rebellion, that's the word.
Hello, everyone. Thanks for coming. This is our second Fuse event of the semester, so welcome, those of you who didn't come before. Yeah, we have a lot of fun discussing things like today we're talking about the age of the Earth. With we have Dr. Wakefield over here on this end. Dr. Wakefield got his PhD at Auburn University, and he spent some time in Kansas City, just a fun fact, training dolphins. So that's pretty fun. And then over here, and we have Dr. Wakefield, he's representing theistic evolution in our discussion. And then Dr. Gilmour, he got his PhD at Penn State University, and he enjoys hiking and hanging out with friends and reading. And some of the classes that each of them offer are, Dr. Wakefield teaches like animal biology and things like that. Also, he teaches part of the evolution course in the bio program. And then Dr. Gilmour teaches a lot of the computer programming classes and things like that from the engineering department. So if you guys could give them a big warm welcome. One more thing, I'm gonna pass around the attendance sheet. And if your name's already on there, you can just check it for your second event of the semester. But if it's not, there's a lot of open spaces for you to write your name and your email address and things like that. Okay, thank you very much.
So thank you all for coming tonight. I hope you really enjoyed this discussion. So the tentative plan is for both of you guys to open with about 5 minutes to talk about your story, your journey, whether it was a journey, just how you got to where you are, and not so much the science at this point, but just more of your story. And then we continue with 15 minutes about to go over your list of evidences or arguments or how you understand how and why science points to a young or old Earth. And then we go to the opposite person to give, say, 10 minutes to address those points. And then after you have spoken, he's addressed, and Gilmour has spoken, and Wakefield has addressed. Then we'll go 5 minutes each for some concluding statements, and then we'll have plenty of time for questions from the audience afterwards. So, if Dr. Wakefield, you would like to open with your story.
Okay. Before we do that, I hope it's okay if we just go ahead and pray first. I'll bless everybody's food in case you didn't do that. I don't want it to spoil in your stomach while we're here. And then we'll go ahead and start from there. So let me pray for us. Lord Jesus, I just thank you for this day, and I thank you for this opportunity to be here. I thank you for the food that you have provided for us. It's a blessing straight from your hand. It's also a blessing to be able to be here with colleagues and with students and have this opportunity to have a time of discussion. Lord, we just pray that your Spirit would just be here in our hearts and in our minds, being here in a weighty sort of way. When I mean weighty, I mean that we can feel your presence here with us today. And I just pray for the words that come out of my mouth, out of Dr. Gilmour's mouth, that they would be pleasing to you, that they would be things that would help students as we discuss this issue, which we all know can be a rather contentious and hard issue to deal with as we're trying to make sense of our calling in life and our faith in you and in your word. We just pray, Lord, that you would just be here amongst us, and I just pray these things in your name. Amen. Okay, so my story about how my journey got here. So actually, there's no story. I just sort of popped into existence right here about 10 minutes ago, so that's it. My dad is a Southern Baptist minister, retired. He now resides in Missouri. So I grew up in the church, always going to church. I guess I went to church probably the first time when my mom carried me in on a blanket. I always wanted to be a biologist. When I was a little kid, I used to watch Jacques Cousteau specials on PBS, and so I was always intrigued with the ocean, and so I wanted to become a marine biologist, and unfortunately I was stuck in a landlocked state like Tennessee and Missouri and so forth. but that was always my dream. And so I just kept pursuing that, and then eventually worked my way to an actual state that actually had a coastline. And so, as Peyton said, I got my PhD from Auburn University. So I went to a Baptist college. Some of you may be familiar with Union University in Jackson, Tennessee, and got my bachelor's degree in biology. And then I went to the University of Missouri in Kansas City and got my master's degree in biology. And then eventually went to Auburn University and got my PhD in zoology, specifically studying corals and the relationship that corals have with a type of microscopic algae. And I don't want to bore you with all the details. If you're really that interested in it, you can talk to me about that some other time. But anyway, that's got my PhD there. When I graduated from Auburn University, started looking for a job, and my wife and I kind of drew a circle and said we need to find a place somewhere around here where our family is at, because we'd been away from our family for about closest family was about 15 hours away. We had two little children at the time, and so we wanted to get closer back to home. And so job opening came up at JBU, and so I applied, and they didn't respond right away. They looked for some other people, which of course was a big mistake on their part. And, so after they went through that first round of people and they said none of those will fit, then I got invited, and that's how I wound up here at John Brown University. I've been at JBU now for 17 years, and as Peyton said, courses that I teach, I have taught a lot of animal biology in the past. So animal biology, I teach human anatomy. So if you see or you smell the cadavers when you come through the building, that's one of the courses that I teach, is the human anatomy class with the cadaver dissection. I'm also currently teaching Anatomy and Physiology 1 for the nursing students. I also am now, we just started a brand new course called Ecology and Evolution, and I'm teaching the evolution portion of that class. I see some of my students are here, so thanks for being here. And then in the spring, I teach human physiology. I teach a class called Global Environmental Stewardship, which everyone should sign up for this next spring. You'll really like it. It's a great class. And teach also a faith and science class, which is a capstone class for our science majors. And occasionally teach marine biology, which was the thing that I really was trained to do. So I do teach a marine biology class here, but every summer I also go and teach a marine biology class in the Pacific Northwest on Whidbey Island, which is just off the coast of Seattle. So even though I started as about an 8-year-old loving Jacques Cousteau, I eventually did get to do what I wanted to do, which was be a marine biologist. Okay, so that's kind of my story.
First, I want to say it's an honor to be here next to Dr. Wakefield. I have a lot of respect for him. So I'm Tim Gilmour. I've taught electrical engineering here at JBU since 2012. And I grew up in New Jersey, got a bachelor's degree in electrical engineering from Cedarville University in Ohio. And I just kind of grew up enjoying electronics, playing around with motors and lights and transistors and stuff in the basement. It was really fun. And then thought, well, if I can't think of anything better to do, I'll just be an electrical engineer. And so that worked out pretty well, enjoyed that. Got to the end of my undergrad and felt like I want to learn more. I feel like I'm sort of half done learning in school. So I ended up going to grad school and went to Penn State. And I was in senior year looking around, and I found this interesting article about monkeys controlling robots with their brain. And I thought, oh, that's really neat. I could never do that, but that's cool. And then I went to Penn State and found that there was a professor who was doing brain-computer interfacing, and he was looking for grad students to work with him. So I got connected there and got to do some brain-computer interface work. And then I was looking around, felt like I wanted to go on for a PhD. So there was another medical doctor who was looking for someone to do brain recordings in Parkinson's disease. So I got to work on that with the electrical engineering side of that, and that was pretty cool. And then 2011, 2012, I was starting to apply for jobs, look around, and I had actually never heard of John Brown University, but someone from my alma mater, someone from JBU contacted someone from my alma mater, got connected to me, and I came down. First time I heard of John Brown, I thought, oh, is that the abolitionist? But no, he was the evangelist, different guy. And so I really liked it here, and I've been here since then. I teach computer programming, digital systems, digital communications theory. I taught control systems once. I teach embedded systems. So just sorts of electrical, programming, digital types of things. That's about it.
Okay.
So, Dr. Wakefield,
Yes.
if you could, say, take about 15 minutes to talk about the evidence you've lined up, prepared for us about why we should believe that the Earth is old, and why it's important to you particularly.
Okay. Let me start with the second part of the question first. Why is it important to me particularly? It's not really particularly important to me. I think one of the things that I want to start off by saying is that God is sovereign, and God can do whatever He wants to. And so it's not particularly important to me that the earth is old. It's important to me that we find out what God's truth is. And because God is the author of Scripture, and because God is also the author of everything that there is in creation, those two things can't be in conflict with each other. They have to actually be together. They have to be concordant together. So that's why it's important for me that we find out what I think the truth is. And so it's not important to me that the earth is old. That doesn't really matter. If I thought that the evidence showed that the earth was in fact very, very young, then that would be fine, because God is sovereign. He can do whatever He wants to do. So this is really just a matter of trying to figure out what's really true. So what do I think that the evidence shows? All right, so let me just start with some things that we can find right here on the earth. So if everyone's familiar, of course, with annual rings in trees, and that for every year that a tree grows, it'll form an annual ring. And so if we just use tree rings, how old can we go backwards with tree rings? By the way, let me just also say, this is not really my field. I'm not really a geologist or an age of the earth sort of person. That's not my particular field, but I have studied it some. But so if I look at my notes a lot, it's because of that. But by using annual growth rings, particularly in European oak trees, both alive and dead, because you can actually take harvested wood and actually look at the rings that have been in harvested wood and match them up to the wood that's actually still living. You can actually count those rings back, and you can get at least 12,000 years worth of annual rings. Now, 12,000 years is still sort of within the ballpark of what young earth creationists typically think about as far as how old the earth might be. Okay, but let's talk about something else. In addition to growth on trees, there's also annual snowfalls. So if you go to places where it stays cold pretty much year-round, you're going to have an annual snowfall. So let's think about some place like the Antarctic. In the Antarctic, you have both the winter and the summer. In the summertime, the snowfall will melt and it'll sort of turn icy. And as it melts and turns icy, then when the next winter comes, the snow will actually fall on top of that, and it starts compressing the ice into layers. And so you can actually wind up seeing layers of ice year by year by year. And you can actually even see in those layers of ice historical events. So for example, when certain volcanoes were known to erupt, you can actually see in those layers of ice the ash from those different volcanic eruptions and everything. So if you go to Antarctica, where the oldest glaciers are, and you drill ice cores down from the surface all the way down to the bottom, and then count the annual layers of ice in those glaciers, the oldest recorded glacier in Antarctica shows a date of 740,000 years. So that's something that you can literally just measure as those annual rings of those annual layers of snowfall. A lot of times students want to know about radiometric dating. You hear a lot about radiometric dating. Radiometric dating is based off of a process that involves chemistry, radioactive decay of certain elements. Just to give you an example, one that I just looked up recently, you have to know a little bit of chemistry to understand this, but when an element is determined by the number of protons that are actually in the atom, in the nucleus of the atom, and as the atom undergoes radioactive decay, the protons are shot out, and that's what causes it to change from one kind of element to another. So there's a kind of radioactive decay that occurs between potassium-40 and argon-40. Okay, argon-40 is a noble gas. Potassium-40 is not a gas. So, for radioactive decay, you can actually measure how fast that decay occurs. It's what's called the half-life. So let's say if you started with 100 grams of this radioactive material, whatever the half-life of that material is, after that amount of time has gone by, then half of that material would have decayed into whatever the product was. So in the case of potassium-40, argon-40, if you started with 100 grams of potassium-40, 1.3 billion years later, you'd have only 50 grams of potassium-40, and then you'd have 50 grams of argon-40, because it takes that long for half of the material to decay into the next element. So, of course, the thing with doing proper radiometric dating that you have to understand is you have to know how much of each element that you start with, otherwise that's going to confuse your findings. So this is actually a really good one to work with, because when liquid rock comes up from the surface or from underneath the earth, a gas like argon is going to actually bubble to the surface and dissipate away. So there's no argon-40 in molten rock, because it all just dissipates away as a gas. Of course, when the rock solidifies and cools and solidifies, then everything that's left in there is what's actually in the rock. So you can actually take that rock then and measure, and the argon-40 level that's in the rock would be the amount that has come into the rock as the potassium-40 has actually decayed into the next layer down, the next radio element down. So when we look at the Earth, we see how old are some of the rocks. Some of the oldest rocks that have been dated are actually found in Greenland. And these aren't, by the way, potassium-40, argon-40 aren't the only radiometric decay mechanisms that they use. There's lots and lots and lots of them that they use. This just happens to be one that I looked up recently. But using several different isotope measurements, the rocks in Greenland measured out to 3.6 billion years old. 3.6 billion years old. Okay? Problem with using rocks, of course, on the planet is that they're exposed to lots of erosion because of all the different things that happen, rain and weathering and so forth. So it's actually even better if you could get something that wasn't exposed to all that erosion. And we're really fortunate that we actually had that in the form of meteorites. So meteorites that have been actually circling around in the solar system, occasionally some of those actually come into our atmosphere, come and actually land on the Earth. So if you get a meteorite, go right into the center of it, where there hasn't been any erosion, there hasn't been any kind of decaying that's going, or any kind of erosive processes like you get on the surface of the Earth, you can actually get a pretty accurate measurement. And so for all the meteorites that have been found on the surface of the Earth, and they've done these measurements, they give us an age of about 4.5 billion years. So it's because of that, it's assumed that the solar system, our solar system, has been around for about 4.5 billion years. So sun, moon, sun, moon, planets in our solar system are all estimated to be about 4.5 billion years old. Now, what about, how much time do we have?
We have about 7 minutes.
Okay, well, we're doing good. All right, so what about galaxies? Okay, how about the universe as a whole? All right, so to age the universe as a whole, first thing you need to understand is, and you hear this a lot if you like me, watch science fiction films and so forth, about light years. Okay, so what is a light year? So a light year is the distance that light can travel in 1 year. Light is very, very fast. It travels at 300,000 kilometers per second. Okay, so that's really fast. But the extreme distances that are found in our galaxy and in the universe make even speed at light travel a long trip. Okay, so for example, it takes 8.3 minutes from the light, 8.3 minutes for the light to leave the sun and actually come to our planet. 8.3 minutes. So what we're actually doing is looking backwards in time, because the light has been traveling 8.3 minutes before it even reaches the surface of our planet. Okay? The Andromeda Galaxy, which is actually the closest galaxy to our own galaxy, is 2.3 million light years away. So the light that's coming from Andromeda to get to here has been traveling for an estimated 2.3 million years. So what we're actually doing when we look out into the universe is actually looking backwards in time at what that galaxy looked like 2.3 million years ago. Now, here's the thing about making these estimates. To make the calculations, you need to know how far away that object is in order to actually know how long the light has been traveling. So this is where the mathematics goes way beyond me. I have trouble adding up basic math. So we'll turn over here to Dr. Varner to talk about the mathematics. But so you have to do the calculations to know how far away the object is. And astronomers actually use several different interlocking methods to determine the distances, such as the geometric calculations, brightness, measurements, and so forth. For example, we know what the Andromeda Galaxy looks like. We know about how big it is. If we can find another galaxy that's of that same kind, but it's so much more fainter than the Andromeda, then we can assume that the reason why it's smaller and fainter is because it's farther away. So doing all of these calculations and so forth help us to actually know how far away each object is that we're looking at, and then we can determine how long it takes for the light to actually travel to get there. So using these methods, astronomers have actually detected galaxies that are billions and billions of light years away. Now, not only can astronomers measure the distance of galaxies, and this one's kind of really cool, they can also measure how the galaxies are moving. Galaxies actually don't hold still in space. They're actually moving through space, but they're not moving randomly. Some galaxies are actually coming closer to each other, and that's because of the pull of gravity. They have a pull of gravity on each other, so they're pulling towards each other. But that's kind of unusual. The biggest pattern that we see in galaxies is that they're actually moving farther apart from each other. Okay? And this motion away from each other is not actually at the same speed. Instead, it follows a pattern so that the galaxies that are farther apart from each other are actually moving more quickly away from each other, which seems a little bit strange to think about, but the best analogy that I think anybody has come up with is to think about raisin bread. Okay, so if you have a loaf of raisin bread, and you start with the loaf all compressed together so that the raisins are relatively close to each other. And as the bread rises, the raisins that are sort of in the middle are moving away from each other, but because they're in the middle, they don't move nearly as far away from each other as the raisins that are further out in the bread, because it's expanding much greater in the outer edges. So the galaxies that are further away and farther out are expanding and are pushing away from each other even faster than the ones that are closer to the center. Excuse me. So this pattern then shows that all of the galaxies, everything is expanding away from each other. So when astronomers detect a galaxy's motion, what they look at is the light spectrum that's coming from it. And when a galaxy is carried away by the expansion of space, the light waves actually get stretched out. And this is something that probably most of you have heard of. It's what's called a redshift. So as something is moving away from you, the light actually shifts more into the red zone than it does if it's moving towards you. You get that same sort of thing if you're standing on the track of a race car track and you can hear the car coming, and then you hear it as it goes past you, how the tone changes. It's the same thing, because now the sound is actually traveling away from you instead of coming towards you. The same thing happens with light. So as the light is moving away from you, it shifts downwards. And 2 minutes. Okay, it shifts downwards. And so you get this redshift pattern. So, let's see, where am I here? So using the redshift, we can actually calculate the velocity that the galaxies are moving away from each other. and actually measure the expansion rate of the whole universe as a whole. So if the universe is expanding as a whole, and we can calculate about how fast that is, then we should be able to use calculations to reverse that. So if it's now this big, and we reverse that and start pushing everything back together, back towards everything being back in one central place, how long would it actually take for everything to come back into a central location? And the estimate for that is about 13.7 billion years. So the best estimate for how old the universe as a total is about 13.7 billion years. So all of this stuff is based on calculations, mathematics, looking at these different patterns, shifting redshifts, measurements, and those sorts of things. And that's the best that we have as far as science, as far as giving an age for the Earth, an age for our solar system, an age for the universe as a whole. So I think I made it. Yeah.
Thank you, Dr. Wakefield. So Dr. Gilmour, if you could take 15 minutes to talk about why it's important to you that the Earth is young or old, and the scientific evidence that you have brought to us about why the Earth is young.
Okay, sure. And also I forgot to mention, there was a question you asked at the beginning about whether I struggled with science and faith. And I didn't really struggle too much with science versus faith, but I did go through some times of skepticism in my college career, especially around senior year of college. Questions about the Old Testament and the reliability of the Bible and things. And then I found some people who really helped me, and some websites that really helped me to answer those questions. So thank you, Dr. Wakefield. Those were very interesting points you raised, and hopefully I'll get to come back to those or in Q&A. Why is this important to me? As you may know, if you've read the Bible, if you add up the ages of the genealogies and how old the people were when they had their child, you add those all up, you get an age of about 6,000, maybe a little less than 6,000 years from now until back when God created the world. If you just took it as it's plainly written, literally, and God says that He created it in 6 days and so on. So the problem or the issue, why this is important to me, is as we read the Scripture, it seems like that's we have a young Earth, and if we look at these scientific issues that Dr. Wakefield has raised, then how can we reconcile this? 3 issues this raises for me. One is, how do we interpret other parts of the Bible, which seem to be conveying literal history? So, for example, but let's say they're contradicted by quote-unquote science. For example, Jesus' resurrection. The science says that people don't rise from the dead. So, if we're going to look at the different scientific tests that we've mentioned and sort of reinterpret Genesis to say it's not literal, then we may have to start dealing with the same questions about Matthew, Mark, Luke, and John, and so on. Second, what is the character of God? This is a really big one for me. This is a very important reason why this is important. Does God think that, in Genesis 1, I believe it's verse 31, God gets to the end of the creation and He says, behold, it is very good. Now, does God think that predation, sickness, death, suffering, animals killing and eating each other, Guillain-Barré syndrome, cancer, does God think that all these are very good? Or what I believe, that God created the world perfectly, no death or suffering, and then, thank you, and then sin came in, and death and suffering were... We have problems in the world today, such as this very problem that you're seeing at the moment. Yeah, so you can see this major problem then. What is the character of God? Does God think that cancer is very good? Does God love cancer? And is really excited about this sort of thing, seeing humans, animals suffer and die. The third problem is it really destroys what the Bible says about the gospel. So death came after sin or before sin. It really turns the gospel upside down. The Bible says that the first Adam brought sin into the world. This is paraphrasing Romans 5. And then the second Adam, again, Romans 5 and 1 Corinthians 15, did away with sin and brought life and brought forgiveness. That is Jesus Christ. So if we say that death and suffering and all this happened before sin, that really turns the gospel upside down. So what are some things scientifically that might fit better with a biblical, literal view? A few things. The fossil record, really the overall big picture of the fossil record is, you may have heard of the Cambrian explosion. Basically, if you go back to what evolutionists date to about 540 million years ago in the rocks, you have all these layers. And below that point, any rocks that are older than that point just have bacteria or other single-celled organisms. Above that point, suddenly, we have 9 phyla, just basically all the animal types of the world, just a few missing, and then all those show up right after that. And that period is only, let's just say 10 to 20 million years. So there's 3.5 billion years of bacteria, and then a little blip when all of a sudden you have all the animal fossils showing up, and then the past 500 million years, not much evolution since then. And there's no missing links between all those different phyla in that explosion. So this actually very closely fits what we would expect with the flood of Noah's day, where you have the basement layer of rocks, and then lots of sediment that comes in from the flood, buries a lot of animals, fossilizes, and then we see all what we have today. The order in which the animals are buried also fits this. The underwater creatures like trilobites and arthropods tend to be buried in the deepest, oldest sediments, and then animals like dinosaurs and buffalo are higher up in the sediments. And the pattern of fossils, so basically that fits. There's a common perception that fossils can take millions of years to form, but actually that's incorrect. Fossils can form very quickly wherever you have water that has a lot of minerals in the water. For example, there's a natural spring in England where people hang teddy bears right underneath the spring, and then the mineralized water fills up the teddy bears and turns them into fossilized teddy bears within a few months. So it's really not a problem to fossilize things fast. In fact, it's a problem to fossilize things slowly. You look at something like the Green River Formation, where you have millions of these little layers called varves by some people, but we have all these fish throughout the layers. And if you think about it, a fish that's sitting there for millions of years, slowly being covered up by dust, it's probably not going to last that long. It's going to be eaten by scavengers, bacteria, and so on. So the problem that you have all these fossils that we find are really showing that some catastrophe buried them quickly in water so that you could permineralize these things very quickly. It's really good evidence for the flood. By the way, in the last 10 years, scientists have found that inside many dinosaur bones, where the outside is fossilized, some of the insides are still soft and squishy and stretchy. And this is very surprising for people who think it's tens of millions of years old. In fact, when they tried to publish these, the scientists said that's ridiculous, and they couldn't get it published for many years. And finally, Dr. Schweitzer and others have gotten these published. And the science says that after just 6 million years, there should be no DNA left, and that's considering refrigerating it at -5 degrees Celsius. If you could refrigerate these things in the ground, there'd be no DNA left. How much more, but they're still able to actually sequence DNA from dinosaur bones, which are supposedly 66 to 80 million year old Cretaceous bones. So there's a lot of stuff buried which really can't be that old. It fits much better with the young Earth that the Bible talks about. Other geology. Many of you have noticed that if you look at the layers and road cuts inside of the road, you'll see a lot of strata, a lot of layers, and sometimes they'll be bent, sometimes bent very tightly. In fact, there's a spot right over here on 412 between Silent Springs and Springdale where you can see tightly bent layers. And if you look carefully at it, there's no cracking between the layers. So that means those layers were bent while they were still soft. So people normally look at layers and they say, well, this must have been laid down in millions of years. But that can't be because all of these layers were bent together while they were still soft. They can't have stayed soft and squishy for millions of years. So again, all this stuff really fits, the geology fits very well with the flood. How about Mount St. Helens? You guys have probably heard of Mount St. Helens, erupted in 1981, 1982. So the Grand Canyon, as you know, people say it took millions of years to form, but there's a small scale version of a Grand Canyon in Mount St. Helens, in which they had, for example, 40 feet or more of finely layered strata, which were laid down in a single day. And then you have this big canyon, which was again cut by the dam break of, I believe it's Spirit Lake, and just cut this channel right there, like a 1/16th scale version of the Grand Canyon, again in one day, in a few hours. And then people start to look at this and say, oh, this thing looks like it was made over millions of years, but obviously we know it wasn't. So similarly, things like the Grand Canyon and other places can be made that fast. Now, radioisotope dating, how many minutes do I have left?
You have about 6 minutes left.
6 minutes left, okay. So Dr. Wakefield raised radioisotope dating, and as he mentioned, it assumes we know the rock's initial conditions, and that the rock has remained a closed system for millions of years, and that the radioactive decay rate has remained constant for all that time. Really, all three of these are found to be unreliable in some cases. For example, some Mount St. Helens rocks from the top dome were dated, and we know when that erupted, when that was about 30 years ago, but they dated to millions of years old. And so the people who are making these dates will say, well, that must have been excess argon, something like that. So they can come up with different explanations for why it's inaccurate, but if you can't trust the method when you know how old the rock is, then why should we trust it for supposedly billions of years old when we don't know? That's what it seems like to me. Why would we trust some of these methods? Now, some of the methods that have much shorter half-lives, like carbon-14, actually, carbon-14 has been found in coal, which is supposedly millions of years old, but actually, if you tried to let carbon-14 stay there for millions of years, it would all disappear. You can't have carbon-14 in any items that are about 100,000 years old or more. Otherwise, there's no carbon-14 left. But we found it in all coal, essentially, in dinosaur bones, whatever bones have been dated, diamonds. And actually, diamonds are very interesting because it's very hard to contaminate a diamond, because how would you put a contaminant inside a diamond? You can't get it inside the crystal structure. But again, it has carbon-14 remaining in it, so even though it's supposedly tens of millions of years old, it can't possibly be that old. So basically, there's a lot of results which are not consistent with billions of years from radioactive dating. But there are some results, like from carbon-14, that are consistent with young ages. A few others that I'll mention, the magnetic field of the Earth is decaying too fast. It decays about 5% per century, and we can measure that. So the Earth must be less than 10,000 years old. Otherwise, the field would be too strong for that. And there's a lot of details we can go into about that, about reversals and other methods, but we can talk about that in Q&A. Now, how about biological material decays too fast? So DNA, as I mentioned, has been extracted from very old things like dinosaur bones. It's also been extracted from insects and amber, which are, for example, 135 million years old, supposedly. And DNA is not a very stable molecule. Not only can it be destroyed by chemical means, but it just falls apart naturally. Cosmic rays and whatever else, heat just causes the DNA to decompose. And so this is not refrigerated at -80 Celsius. This is just sitting there at room temperature at amber, but they can extract DNA from these things. Neanderthal bones, and there's even been bacteria which have been revived from spores in 250 million year old rock, and put the spores in water, and then the bacteria come out, and they're quite healthy. It's pretty amazing. So I don't really think it's that old. I think it's just a few thousand years old. Finally, if you look at the mutation rates of the genome, and you could look at mitochondrial mutations or just the full genome, and it turns out that these rates point to a young genome, that the genomes we see today have only been diverging from a common ancestor for about 6,000 years. This was shocking when the evolutionists came up with this rate for what they call mitochondrial Eve, that it might be that young, but in fact that's what it shows. And as they'll announce, I think Dr. John Sanford is planning to come and speak next month here at Fuse, and he has a lot of experience. He's a geneticist from Cornell University, and he is maybe talking more about mitochondrial Eve and some of those things. So I'll just mention there's a lot of evidence in that regard. How many minutes do I have left?
You have about 2 minutes.
Okay. I would say that the most important thing for me in determining the age of the earth, or why is this important, what's the big picture, is I look at the Bible, and the Bible seems pretty clear that, look at the genealogies, it was all literal history. You can't fit millions of years or billions of years anywhere in there. And if you look at how Jesus and Peter and Paul and others interpreted the Bible, they always interpret it as literal history. They didn't interpret it as metaphorical or allegorical. So I want to follow their lead and say, okay, that's how I'm going to interpret it also. And then when I look at science, I see very strong evidence that fits this young earth paradigm. Hopefully, in a few minutes, I'll get back and sort of examine the evidences that Dr. Wakefield mentioned, the annual layers, the tree rings, the ice layers, the radiometric dating. I think I've already touched on the radiometric dating, but I'll look at the tree rings, ice layers, and the galaxies.
Thank you, Dr. Gilmour. So Dr. Wakefield, if you would take 10 minutes, if you so choose, to address any of Dr. Gilmour's points.
Okay. Well, I must admit that, like I said, I certainly don't know everything. I would really be interested in seeing the papers that have been published that say that you can actually get squishy stuff out of the middle of the dinosaur bone in a peer-reviewed journal article. So be sure and send me a link for that. As far as getting DNA evidence from things that are less old than a dinosaur, like a Neanderthal or a Denisovans, those sorts of things are actually a little more understandable because those hominids were actually contemporaries with Homo sapiens, so they're not actually quite as old. But I've never heard of actually extracting reliable DNA samples out of a squishy dinosaur bone, so I'd be really interested to find out about that. Other things, as Dr. Gilmour mentioned, the dates, when you look at the genealogies in the Old Testament, particularly in Genesis and so forth, and start trying to figure out how old the earth is from those genealogies. One of the things that Old Testament scholars will be sure to tell you is that the ages for the people that are listed in those genealogies, so for example, Methuselah, who lived 900-something years old, Enoch, who lived however many years, that almost universally Old Testament scholars will tell you that those are not accurate real years, that those are, they're hyperbole. They're actually put down there to actually emphasize the fact that as sin had more and more effect on the world, that people, you could start to see that and one of the ways that you could see that was in the fact that people had more and more problems. They couldn't live as long. But the actual ages it was actually exaggerated for that purpose. We had a Old Testament scholar here on Wednesday afternoon, a very well-known Old Testament scholar who is actually right now in the process of writing a book on the flood himself. And when he was asked, as far as Old Testament scholars across the board, how many of those Old Testament scholars actually would fall into a young earth creationist camp, and he basically said none. Because Old Testament scholars can, when they read the Old Testament, know that those things are not meant to be taken as literal dates, literal years, that they're actually exaggerations to exaggerate a point. And this is one of the things that we have to understand about the Old Testament itself, is that it's a type of literature. It's not like reading a newspaper article that is published for us today. It was written for people, it was written for a group of people in the Near East that time period, and it was a particular kind of literature, and it followed the same sort of pattern as other kinds of literature of that same genre. So to try and take that literary piece and make it fit into what we consider to be a scientific treatise or a piece of history in that same sort of vein is really a sort of a mistreatment of that literature. My opinion is that, and this was also Dr. Templer's position, is that the Bible is inerrant, that there's no mistake in it. It means to teach what it means to teach, and so therefore there's no error in it. But the purpose of those stories is not meant to teach us exactly how God created everything in a 6-day period. In fact, if you go back and actually read some of the earliest Christian writers from 100 AD, talking about Origen and St. Augustine and so forth, they did not ascribe to a literal 6-day, 24-hour creation. In fact, they were actually looking at from the other direction. They basically said that it would have been, why would God need 6 days to create? God is all-powerful. He could do everything. And in fact, he did do everything in the blink of an eye. It was just he spoke it and it happened. So then why put it all down as a 6-day? And they would say it was because he was trying to outline something so that people could understand it, so that they could understand it in a regular 7-day work kind of week. But how can you actually have an evening and a morning in day 1, 2, and 3 when you don't have a sun until that's created on day 4? So that's a big problem when you're trying to make that process fit into what we understand as far as how the scientific world, how the natural world works. So the whole idea of a young earth creationist position actually is a relatively new position. It only really came into existence in the early 60s through the work of Ellen G. White, who I'm not sure if any of you have ever heard of Ellen G. White, but she was the founder of the Seventh-day Adventist movement, and she basically said that she had visions, and in these visions God took her backwards in time so that she could actually see the actual creation event and actually see the flood. And so she actually became an eyewitness. This is her own accounting. She became an eyewitness to the creation and to the flood event. And she wrote all these things down, and then she had a disciple, a guy by the name of George McCready Price, who came behind her. He was not a trained scientist, but he took it upon himself to actually prove that what she had said was correct. And so a lot of the Seventh-day Adventist following came up and followed right along with George McCready Price and Ellen G. White on this. So that happened, like I said, in the early 60s, and that was really the start of what we now know as modern-day young earth creationism. So it's a relatively new as far as Christian apologetics goes. If you go back before that time, obviously there were people who thought that the earth was young, but it was never an issue. It was never a lot of conflict for people who thought otherwise. In fact, I have a book right here that was borrowed from Mrs. Beers. It's called Evolution and Christian Thought Today. It was actually published in the late 50s, and it was actually a book that one of our professors here at John Brown University, Gaston Griggs, who was one of our biology professors, used to teach here. And this was actually a book that was used by him before the emergence of young earth creationism. And so even in this point in time, it just shows that this wasn't really that big of an issue. You brought up the issue of of the Grand Canyon. There's a new book that's just been published, The Grand Canyon Monument to an Ancient Earth, which was actually written by Christian authors. And if you go to the Grand Canyon, you can actually get a copy of this book, or of course you can order it on Amazon. But it basically goes through all the evidence that's in the Grand Canyon to basically show that the Grand Canyon was not formed recently, as Dr. Gilmour explained, could happen, which obviously in the case of Mount St. Helens, you actually did have a situation where it did form a canyon-like structure, but that's not the same thing as the Grand Canyon. And so there's a lot of great information. It's really an interesting book, a lot of great photos and so forth to explain that the Grand Canyon actually is an ancient geological site, and that it was actually carved out by the Colorado River over a long, long, long period of time. So again, the whole point, and I probably didn't answer any of your specific things, but the whole thing that I want to try and convey is, like I said, God is sovereign. God can do whatever He wants to do. The reason why I tend to not think that the earth is young is because I look at the evidence, and the evidence that's presented, it doesn't look like it. And I've been studying it for a long, long time. And so I have a real problem with a God who would put so much evidence out there that seems to point to the earth is really, really old when it's really, really not. Because then I have to ask the question, and it goes really, again, just as Dr. Gilmour said, it goes to the character of God. Is God someone that we can trust? Is God someone that we can believe? If the earth really, if there's all this evidence that seems to show that the earth is really, really old, then when in fact it's really, really young, then it makes me question, can I really believe and trust what God says? And so that's the really key or the critical issue for me. I want to be able to say, yes, I think it's old because this is the evidence that I see, and I think I can make this match up with my faith. I can take my faith and hold on to my faith and hold on to this evidence as well, and still be true. I don't think that we have a problem with looking at Matthew, Mark, Luke, and John because those things happened when people were there to see them happen. And so, in fact, if you read the Gospel of Luke, he says, I'm writing these things down because these were the things that people told me. These are things that actually were seen and reported. When you go to the creation story, you don't have that. Okay, you don't have an eyewitness account to that. All you have is just what was reported, or if we understand correctly, what Moses wrote down. So Moses wasn't there when it happened, so we have to look at the literature for what it is. What is the literature trying to say? So it's very, very different trying to make that connection between the Gospels and things that happened when people were there, were eyewitnesses for those things.
Thank you. You've raised a lot of great issues. I hope we can get to some of these in the Q&A. Let me first mention, is God trustworthy? I think that's absolutely a very important question. And Dr. Wakefield is saying that the creation we see around us is sort of another testimony from God, and it has to match up with the testimony from the Bible. But actually, I would say to you that creation is not actually a testimony by itself. There's no words. There's just some facts that we see. We can do tests, scientific data, and then we have to interpret it somehow. And you can interpret it in either way. And I would say, as I look at the data, the interpretation of the data is actually much more consistent with the young Earth than an old Earth. There's no text. You don't dig up a rock that says 4 billion years. You do some tests on it, you do some interpretations. So, is God trustworthy? And I would come back to the Bible. The Bible is actually text. There's linguistic meaning, objective meaning associated with the text. And if we can't trust the Bible, now, Dr. Wakefield says he believes in inerrancy, that the Bible is inerrant. But he also said that the genealogies are hyperbole, he says. Basically, when Methuselah lived for 965 years, he says, no, that's not actually true. I don't consider that inerrancy, to be with all due respect. I think that's a problem. If you're going to take the Bible and say those ages are not correct, you're basically saying there's errors in the Bible. So what if you applied the same approach to other scripture? Now, Dr. Wakefield, he said there was hyperbole and exaggeration and so on to show the effects of sin, but there's no evidence, he said. It's just he doesn't think it fits, so he's not going to believe those numbers. But if you apply the same approach to other scripture, you know, 1 Chronicles, Samuel, oh, these numbers, we don't like these numbers. We don't think they're going to fit. So I think that's a problem to your interpretation of scripture. Dr. Wakefield mentioned the type of literature. It's basically like cosmogony, not a literal scientific type of thing. But actually, if you look at the grammar and the context, it is actually historic genre. It's literal narrative history. You can look at the grammar. It's a call, I believe it's a call predative that starts out past tense, then it finishes up with law consecutives after that, which is basically the standard Hebrew form for all the other narratives in the Bible. There's no parallelism, which would be a mark of poetry, so it is actually designed to be taken as literal history. Dr. Wakefield mentioned some of the early church fathers, such as Augustine and Origen. Now, what Dr. Wakefield did not mention is that actually the vast majority of Christians throughout all of church Bible interpretation have taken Genesis as literal. I can name just a few here. The author of 1 Clement, Justin Martyr, Theophilus of Antioch, Basil of Caesarea, Nicholas of Lyra, and so many more, all took Genesis literally, and I can give you quotes for them. Likewise, all the reformers, Luther, Zwingli, Calvin, Bullinger, it was the consensus of all the church for thousands of years that Genesis was literal. There were a few people here and there throughout, such as Origen, which Dr. Wakefield mentioned, who did not take it as literal. Now, Augustine is an interesting case because when he was younger, he came up with this sort of text about Genesis, which he did not take it literally. As Dr. Wakefield mentioned, he sort of thought maybe God created the whole universe in one moment and then just wrote the days after that. But as he got older, he started to think more about Scripture. He wrote this book, The City of God, and you'll read there's a quote, for example, about the days 1 through 3 before the sun was created, and how could that be literal? Well, Augustine says, quote, "What kind of light that was, and by what periodic movement it made evening and morning, is beyond the reach of our senses. Neither can we understand how it was, and yet must unhesitatingly believe it," end quote. So basically, he came to a different understanding as he understood the Scriptures more and started to learn more about the languages and realized, oh, this is actually literal. So there were just a few people, and actually people like Origen, again, very heavily influenced by Neoplatonic thought, trying to squish that into the Scriptures. And he was actually expelled from the city for being a heretic. It's probably not the sort of person that we want to be basing our interpretation of the Bible on. Now, yes, after Darwin and Hutton and Lyell in the 19th century, all of a sudden interpretation started to change and there was a lot of shift. But that's because people were interpreting, using these evolutionary assumptions and ideas to interpret the Bible, not because the text said that. Now, there were some things mentioned about the layers, the tree rings and the ice layers and so on. You can interpret these in different ways, but if you actually look at tree rings that are counted, where you actually do a chord and you count all the rings, the oldest ones, the ones that have a continuous record, are actually the bristlecone pines, I believe, in California. And you can check me on this, but the oldest rings we're seeing around 4,600 years. And Dr. Wakefield mentioned 12,000-year-old ones from Europe. But actually what they're doing is they're taking different pieces of wood, dating them with carbon-14, and then trying to line them up in sort of a sequence to make this record 12,000 years. And there's actually problems with dating carbon-14 right around the time of the flood because with the flood came and it buried this huge amount of carbon, all these plants and animals. And so the ratio of carbon-14, which is generated in the upper atmosphere, to regular carbon-12 would suddenly change at the time of the flood. It's a non-equilibrium system. So you'd expect dates from around that time to be a little off, a little bit old. So when you try to put these together with carbon dating, you get these 12,000-year-old tree records. But when you actually look at a single tree, you don't get anything more than 4,600 years. And interestingly, some of the trees in the same family of these bristlecone pines have been shown to form more than one ring. And that's not a guess, it's been actually shown. If you have a tree in a dry environment and then a rainstorm comes through, it generates a ring, and then another rainstorm comes through, it generates another ring. So a lot of these records And you'd actually ask yourself the question, why would it not be more than 4,600 if these trees could live for thousands of years? But we don't see anything beyond that point, indicating that it's actually fits better with the flood. The ice layers, again, after the flood, you think about the